Hey, seventh graders, this is Mrs. Locke here to help you out with your lesson. Sometimes I record videos that are the video notes, and sometimes I will record the whole lesson, specifically if I want to talk about it a certain way or if we have a certain tradition in how we do things. We don't have our traditions yet, but I do want to talk about this a very specific way. So today and tomorrow will both be on video. You're going to need to have the papers that look like the paper that I'm talking about. So today's paper looks like this. It says 2.2.6 integer subtraction of positive numbers. And then tomorrow's paper looks very, very similar, except it says negative. So you want to be careful because they both look fairly similar. So what we're going to do is we're going to start by subtracting positive numbers. And I want to remind you that in elementary school, when you were subtracting positive numbers, you would move a very specific direction on the number line. Now, before I get going, I want to remind you that you can pause this video because everything I write, you should be writing. I'm going to use color for these kind of notes for the lesson. You do not have to use color unless you want to use color. That's up to you. I will write in gray when I'm expecting pencil. The video notes have to be in color, but the in-class notes do not need to be in color. Let's dive in. When you were in elementary school and your teacher was teaching you how to do like 15, I already shouldn't be in color. Let's say 15 minus 7. What you learned was, actually, I'm going to move that. So I'm going to move that to the middle. What you learned was that you start here. You move 7 and you end somewhere. That's kind of what we were taught. So if I started at 15 and I was going to subtract 7, I would go maybe minus 5 and then minus 2 more, and I ended at 8. All right. So that's one way we did it. Another way we did it was that you started at 15 and then you jumped to 7 and then you figured out how many jumps you did. But I like to say that our jumps moved right here, and that is this number. All right. Notice that we moved left. We moved left. I think this is the easiest way to think about subtracting a positive number is that we move left. You can also think about it as as losing a number or losing money. So let's keep going. Let's say that you've got negative 5 minus 8. We're going to start at negative 5. We're going to move 8 to the left, and then we end. All right. So let me see here. I'm going to start at negative 5. I'm going to subtract 8. So here's 5. I have to do 3 more. So that's negative 8. Not negative 8. That's minus 8. And I ended at 18. Notice if you are using color, I'm putting very specific parts in color. So that's important. That's important. Something that I would love for you to notice on this number line is that moving left is the same as adding a negative number. When we add a negative number, we also move left. So some people change a subtraction sign to adding a negative. And that's actually what we're going to investigate right now. So we're going to set this up with -2 minus, actually not -2, sorry. +2 minus, I don't know, 7, no, 8, no, 9. And then we'll also do this one over here. All right. So we are going to start here, move here, and see where we end. So here's 2. I'm going to jump 2 to the 0 because the 0 is a great landmark. I've only jumped 2 though, so I have to jump 7 more so that I've jumped 9 jumps. And I ended at -7. Now I'm going to show you what some people like to do, and I like to do it too actually. Moving left works for subtraction, but it also works to add a negative number. When you add a negative number, you also move left. So if I start at 2 and I add a -9, I'm going to be going the same direction. What's difficult about that is that sometimes people forget you have to change this sign and change this to a negative. If you only change 2 plus 9, then you end up moving right, and it's problematic. You're not doing it right. So if you notice, we ended up in the same place, whether we subtracted moving left or we added a negative number moving left. So we're going to try that one more time. I'm going to start with -7, and I'm going to subtract 3, and we'll set it up over here. Oh, I put them kind of close. I can change mine, but you can't always change yours, I know, so you can leave yours close if you want there. We're going to start at -7, and we're going to move 3 to the left. So here I go. I'm starting at 7, and I'm going to move 3, 1, 2, 3 to the left. And I ended at -10. But what we could also do is think about, and when you do this, you don't actually change your starting place. So my starting place is going to stay -7. What you end up changing is your operation sign, and you're changing the other number that was positive to a negative. So I'm going to change my operation sign, and I'm changing my positive to a negative because they both move left. So here I go. I'm going to move 3. I'm going to add a -3. And I ended up at -10 anyway. What's nice about that is that you can do it either way, but you get to the same place. Now, the chip model for subtraction is a little bit wackier. I'm going to show you the chip model, and then we're going to come back to this practice. So you don't have to write anything down that I'm saying right now, but I would pay really close attention. So here's what happens with the chip model. I'm going to say that these yellow chips are positive and these red chips are negative. So let's just say, oh, wait, we're not even going to do that. We're not adding chips. Nope. All right, so we're going to do 3 minus 5. All right. And for me to take away 5, I don't have any negative chips on the board. I don't have 5 to take away. I have 3 positive chips on the board, no negative chips, but I have to get rid of 5, and I can't get rid of 5. But what I could do is I could put on a 0 chip. This 0 chip does not change the value. It's still positive 3 because those two chips cancel each other out. One positive and one negative make 0. So I'm going to put a 0 chip on the board. Do I have enough to take away 5 positive chips? Not yet. So I'm going to take another 0 chip and put it on the board. And the reason that I can do it is that these 0 chips cancel out and these 0 chips cancel out. That's why they're called 0 chips. So really, I have not changed the value on the board. Oh no, I gotta erase everything, boo. But now, can I take away 5 positive chips? I sure can. 1, 2, 3, 4, 5. What am I left with? -2. So on the number line, what I had said was you're at 3, you jump 3, and then you have to jump 2 more to jump 5 total, and you end up at -2. Another way to think about it is that I'm going to end up with -2 chips because I end up putting 0 chips on the board. And I know that that's crazy. So it sounds crazy. I actually think it's kind of cool. But if you like the number method, the number line method better, I'm totally okay with that. I'm going to give you another example. Okay. I'm going to just clear the board. Let's say I'm going to set up -4 minus 2. So I have -4 chips. 1, 2, 3, 4. These are all negative chips. And I want to take away or cross out a +2. Do I have any positive chips to cross out? Sure don't. So what I'm going to have to do is I'm going to have to put a 0 chip on the board. I want that to be up there. That's my 0 chip. These two are going to cancel out. Ooh, but I'm not quite done yet. I'm going to put another 0 chip on the board. Oh, and these two will cancel out because they're 0 chips. Now, can I get rid of 2 positive chips? The answer is yes. 1, 2. But look at, I'm left with -6 chips. On the number line, I would have said you start at -4. To subtract 2, you have to move to the left. And I ended at -6. In the chip method, it shows you that like you end up putting more negative chips on the board as 0 chips so that you can cross out the positive ones. And that happens no matter what. Okay, we'll clear the board. I'd love to do another one with you. Let's do like 7 minus 7 minus 10. So I've got 7 positive chips on the board. Sorry about that. 7 positive chips on the board. 6, 7. But at this point, I don't have enough to take away 10. And I think I've said before that in elementary school, they told you that you just can't do it. And that's not true. It's just that it's complicated. So right now I have 7 chips on the board. Can I take away 10 positive chips? I can't. But what I could do is I could add a 0 chip. That would give me, that would, 1, 2, 3, 4, 5, 6, 7, 8. Still not enough. So I'm going to put on another 0 chip and another 0 chip. So I have not changed the value because these 0 chips cancel each other out. But notice now I have more yellows on the board and I'm able to get rid of 10. 4, 5, 6, 7, 8, 9, 10. And the only thing left is a -3. Now on the number line, you would have started at 7, you would have jumped to 0, but you only subtracted 7. So you have to subtract 3 more. That's how you end up at -3. There's 2 ways to do it, subtracting. Just make sure if you're using the number line, you're moving left. And if you're using chips, you're putting 0 chips on the board to help yourself out. So I'm going to go back to that paper and we're going to try the chip method a little bit more. So let's take a look. If I've got 3 positive chips, can I take away 4? No. What I need to do is attach a 0 chip like that. Then can I take away 4 positive chips? Absolutely. I'm left with -1 chip. All right, if I have 12 positive chips, 4, 5, 6, 1, 2, 3, 4, 5, 6. Can I cross out 7? Yes, I can. 1, 2, 3, 4, 5, 6, 7. There are 5 positive chips left. Feel free to stop the video if I'm moving too fast. You can join me. So if I have 3 negative chips, 1, 2, 3, and we are going to subtract a +2, that becomes problematic. I need to put a 0 chip on the board and another 0 chip on the board. That way I can cross out my +2 and look, I'm left with -5. On this one, I have -5 chips. 3, 4, 5. And they want me to subtract a +10. Are there +10 chips on the board? Absolutely not. So I'm going to have to make a 0 chip. I'm going to have to make lots of 0 chips. Can you guess how many 0 chips I'm going to have to make right now? All right, I have 1, 2, 3, 4, 5, 6 positives, but I need 10. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oof. 10 0 chips allows me to cross out 10 positive chips. And I'm left with 15 negative chips. All right. So the chip method is chip model is another way to subtract positive numbers. I want you to practice, and in your practice, you can, your practices are down here. And these, we're going to mix it up a little bit. We're going to do the first 2 with the chip model, and I wouldn't do the first 2. I would maybe do, I don't know. Yeah, let's do the first 2 with the chip model. So I've got 16 positive chips, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 8. 8 and 8 is 16. All right. but we want to take away 25 positive chips. Do I have enough chips to take them away? No. So I'm going to have to add a 0 chip. I'm adding a bunch of 0 chips here. 16, 17, 18, 19, 20. Here's 21. 2, 3, 4, 5. Do I make 25? 17, 18, 19, 20, 21, 22, 23, 24, 25. All right, now I have 25 positive chips. And since I put those 0 chips, it still actually is 16. So I'm going to cross out 25 chips. Oh my goodness gracious. So much chips and so little time. We've got so much chips and so little time. So much chips and so little time. We've got so much chips and so little time. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9. We're left with 9 negative chips. All right. All right, so we've got 7 negative chips. 4, 5, 6, 7. Can we take away 9 positive chips? The answer is no, we don't have enough. So I'm going to have to add a 0 chip, but not just one. I need 9 0 chips so that I can take away 9 positive chips. 4, 5, 6, 7, 8, 9. All right. So 9, I'm going to take away 9 positive chips. And I'm left with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 negative chips. Woo! That's a lot. Let's use the number line for these. What I said earlier is that we could rewrite the subtraction to add a negative because we're going to move left. And when you move left, you can subtract, or you could use adding a negative. What you have to make sure and do, though, is change both signs, the operation sign and the number sign. You have to change both of them. So here I go. I'm going to start at negative 16, and I'm going to subtract 13. So I'm going to go back to 20. I'm going to move 4 to 20. And then I have to move 9 more to get to 13. So we end at 29. And you can think of it as subtracting 13, or you can think of it as adding a negative 13, because a negative 13 and subtracting a positive 13 both move to the left. So here I go. I'm going to do the same thing. I can, because I'm moving to the left, I can rewrite this as 25 plus a negative 76. I have to double check that I changed my operation and my number sign. So now I'm going to start at 25. And I have to move 76, but I'm just going to move 50 first. If I move 50, I'm at 75. But I didn't quite move enough because I have to subtract 76, and I only subtracted 50. So I'm going to go back another 25 to 100. Ooh, don't forget your... Ooh, did I do that wrong? I think I did. I'm going to have to erase that, guys. Sometimes you mess up. I might not get it this first time, but I will figure it out. Let me see, I'm gonna get rid of that and that. The reason I messed up, I figured it out, is that I have to cross a 0. I'm not at negative 25, I'm actually at positive 25. So this would be a 0, so I could go 25 jumps to 0, and then I could still go 50 more jumps to negative 50. And I've jumped negative 50 and negative 25, so that's 75, but I actually have to do 76. So I just need to do one more to negative 51. All right, so for the U tries, you can use the chip model or you can use the number line model, but no matter what, you have to draw that model in this box. Your box should look like my box is. Either with number lines, these are called open number lines, so you don't have to use all the tick marks, or you can use the chip model, but you're gonna be doing this with your talking partner. And then hopefully we can talk about it when I come back, but you wanna get that finished. That is your next job. I'll see you soon.